Okay, so now we're going to look at converting binary to decimal and binary to hexadecimal, both of which are relatively simple. So if this is our binary number, 1010, the procedure for converting that to decimal, and I want you to follow the same procedure every time. Later on, at some point, you'll have it down, and then you don't have to do this. But I have a lot of students who they get these answers wrong on tests, and if they just followed the full procedure, they would have got it right. So first, draw the chart. Then within the chart, you draw the powers of 2. So 2 to the 0, 2 to the 1, 2 squared, and 2 to the 3rd. Then you put the values of the powers of 2. So 2 to the 0. Anything to the 0 power is 1. Anything to the 1 power is itself. 2 times 2 is 4. 4 times 2 is 8. So now that we have the values of these places, what that means is 1 times 8 plus 0 times 4 plus 1 times 2 plus 0 times 1. Right? We all know that's what that means. Well, we know anything times 0 is nothing, right? So we can just cross those off. 1 times anything is itself, so those 1's don't matter. So what we end up with is 8 plus 2. So instead of writing this whole thing out, why don't I just cross off the 0 columns and add up what's left? 8 plus 2, and the answer is 10. So in decimal, this is 10. 1010 is 10. Let's do another one for clarity. All right, let's do 1010. Again, first we draw our chart. We put our powers of 2, 2 to the 0, 2 to the 1, 2 squared, and 2 cubed. Then we put their values, 1, 2, 4, 8. We cross off the zeros. We add up what's left. 8 plus 4 equals 12. So that's converting binary to decimal. Okay, so then the question is, how do we convert from binary into hexadecimal? And the answer is we convert it to decimal and then convert it to hexadecimal. So this is 12. 12, if you remember, let's go ahead and draw it out here. In base 10, we have 1, 2, 3, 4. In hex, that would be, and then D for 13, E for 14, F for 15, etc. But once I know that that value is 12, I know that in hexadecimal it's C. Well, what if it's more than 4 bits? What if it's a larger number? So remember that every hexadecimal digit is 4 bits. One of the reasons we like to use hex is because it cleanly converts to binary and vice versa. But what if it's more than 4 bits? Let's figure that one out. So let's say that our number is 101100. Okay? If we want to convert this to hexadecimal, we break it up into 4-bit segments. So 1, 2, 3, 4, and that's where we draw the line right there. Now you might notice, well, that leaves us with only 2 bits on this side. We can always add zeros to the left. I hope you can see that okay. just like it, 79 and 079 are the same, 10 and 010 are the same. So now, just like before, we're going to draw our chart. Just like before, we're going to put our powers of 2. And over here, 2 to the 0, 2 to the 1, 2 squared, 2 cubed. And then the values of those powers of 2. By the way, I don't know why I drew an extra thing at the bottom, an extra row. So cross out the zeros. And what I'm left with over here is 2. So the value of this is 2. This one I cross out the zeros. And I have 8 plus 4. So the value of this is 12, which is C. So the answer to this is 0x2c. So the procedure for converting a binary number to hexadecimal is break it up into 4-bit chunks. For each 4-bit chunk, solve for the decimal answer, and then convert that. And that will always be between 0 and F. It'll always, because it's 4 bits, right? And if a chunk is less than 4 bits, add zeros to the left. It won't affect the final value. Hope that makes sense. And we'll be doing more of these in class, so it should come together.